On motion of a falling object for lab 2. I chose a basketball, and our general task was to analyze the non-constant motion of an object and compare it with two computational models, one taking account drag and the other without drag. So in order to do this, I recorded a video of a basketball falling and I put it into Tracker to interpret the data, and then I recreated this data in GlowScript, one without drag and the second with drag. So some of the principles used were Newton's second law and the momentum principle, seeing as the forces were non-constant and the ball was falling with an acceleration equal to the gravity of Earth. And the programs I used were Tracker, GlowScript, and Excel. So this is my video. As you can see, it's pretty straightforward. The ball is falling from an initial velocity of 0 as it hits the floor. And this is when I inputted it into Tracker. I used the diameter of the ball to get my scale and then marked the position of the ball every 0.1 seconds as my frame to get the position. So without taking drag into account, the most important thing was that the proportionality constant was 0, and I changed the time span and the ball velocity equation and the ball position equation just to make sure that it was taking into account that the forces were non-constant. And when I did take drag into account, I changed my proportionality constant to negative 0.03, and I to allow it to have the best or most accurate final position compared to the Tracker data. And this was my graph. So the observed position is this pink line here. The predicted position, the one based from GlowScript without taking drag into account, is this purple line, and the blue one takes drag into account. As you can see, when you take drag into account, the final positions are far more accurate and the general trajectory is far more accurate compared to simply the predicted position without taking drag. So there was a question about terminal velocity. My ball did not reach terminal velocity. As you can see here, this is the force diagram that was generated with GlowScript, and the drag force pointing upward is far less in magnitude than the force of gravity pointing downwards. And if you see this chart here, so long as the two are different magnitudes, you will still be experiencing some sort of acceleration rather than a terminal velocity. There's also a question of whether terminal velocity would be the same if the object was initially thrown instead of dropped from rest, and the only difference is just that the terminal velocity would be reached faster, and not that that value would change. So in conclusion, drag can alter the computational model for a ball, and yeah, this was my lab. Thank you.